In this video, we'll be talking about some shapes and their properties, specifically whether or not they can have parallel and perpendicular sides. So first, let's define those two words. Parallel means two lines that never intersect or never cross, kind of like train tracks or the sides of a street. Perpendicular means two lines or line segments that come together to make a 90-degree angle or a right angle. Perpendicular lines make square corners, kind of like the edge of your paper. All right, so let's start with a triangle. So the first question, can a triangle even have parallel sides? Well, if you think about it, in order to make a triangle, the three sides all have to cross each other, don't they? Well, so kind of by definition, if they all have to cross each other at some point, they can't be parallel. You also have to think about sort of them slanting inward. So once they slant inward, they can't be run alongside each other anymore. They have to angle in. So a triangle cannot have parallel sides. But what about perpendicular sides? Could you take a 90-degree angle and turn it into a triangle? Well, sure, if we just connect these other two corners. So a triangle can have perpendicular sides as long as they come together and make 90 degrees. We call that a right triangle. All right, so let's move on to trapezoids. So a trapezoid, by definition, is a shape that only has one pair of parallel sides. So here's what that looks like. You've got your pair of parallel sides that never cross, and then you have two other sides that do cross. I mean, I know they don't cross in this shape, but if we were to imagine those two sides extending beyond the actual edges of the shape, eventually they would in fact cross each other. Okay, so a trapezoid has exactly one pair of parallel sides, and the other pair is not parallel. So could a trapezoid then have a right angle or have perpendicular sides too? Actually, it can, and we can still fit that definition of only having one pair. Here's what that looks like. You've got your pair of parallel sides, you've got your 90-degree angle connecting them, and then just the other side is a little bit slantier than this side here. So we've still got our two sides that are parallel, and we also have a pair of sides that are not parallel. That brings us to parallelograms. So while a trapezoid has just one pair of parallel sides, a parallelogram has two pairs of parallel sides. So you've got your one pair that kind of runs along going one way, and then your other pair that is parallel going a different way. Could a parallelogram also have perpendicular sides? Well, yeah, and this would actually be a special case of a parallelogram where we sort of straighten out that slantiness, and that turns it into a rectangle. In fact, a rectangle is just a special kind of parallelogram since it still fits the definition of a parallelogram by having two pairs of parallel sides. It just also happens to have those 90-degree square corners in all four corners. And a special case of a rectangle is a square. Again, a square still has those parallel sides and it has all those 90-degree angles. So a square is a special type of rectangle and it's a special type of parallelogram as well. That brings us to some other just random shapes like pentagons and hexagons. So these shapes can have parallel and perpendicular lines, but they don't always. It really just kind of depends on the shape and how it's drawn. For example, a pentagon, which has 5 sides, could have no parallel sides at all, right? I mean, here, if you see this side kind of slants in a different way than this side and this side, none of those run right alongside each other. So this pentagon has no parallel sides and no right angles. But if we straighten things out just a little bit, we get something like this, which is also a pentagon. It has 1, 2, 3, 4, 5 sides as well. But now, two of those sides are in fact parallel, and two of them form a 90-degree angle. So again, it really just depends on how the shape is drawn. And if we look at a six-sided shape, a hexagon, now you really do have a lot of opportunity for some parallel sides where these two sides across from each other could be parallel, these two sides could be parallel, and these two sides could be parallel. So like I said, it just depends on the shape and how it's drawn for those other shapes with more than four sides.